Hello, Nick. Can you hear me?
Yes, hello.
I can hear you also.
Uh, I got some homework that I want to do today. It's one math question and like a majority of like chemistry regarding mole.
I would really love to talk about mole and math. Of course, you can always ask anything. And
It's
what is
just
the exam schedule? Just for the
the
next week.
exams all the exams regarding math and science are all done. No, no, chemistry is next week. Also got.
Chemistry, right? But not regarding mole or regarding mole.
No, it's not. No, it's not.
Oh, oh. You sure you're okay? We talk about mole, but next week exam is not about mole.
Wait,
I'm okay. I'm okay. I really want to talk about more, but next week there's an exam. What's the balance here?
wait. Let me see where the exam. Okay, wait.
Okay.
In bio is this week. That means it's week 6. Yeah, chemistry is week 7. Okay. I think okay. Chemistry is wait. Huh? Okay. Oh my. Chemistry is 4 chapters. And there is atomic structure, chemical bonding,
Okay.
structure and
Sure.
properties of
Mhm.
materials, and
Mhm.
chemical formulae and equations.
Chemical formula and equation are not yet molar. Equations. Equations. What does that mean? Chemical or equations, chemical equations. I'm sorry. Yeah. So
And
not yet
I think
molar,
right,
not yet.
we should have enough time for like the next week lesson, Monday.
So Monday still have lah, but Wednesday no lah.
Yeah, it should. Yeah, the exam I predict should be on Wednesday. Definitely not
Okay.
Monday or Tuesday because Monday only got 35 minutes of
All right.
chemistry.
Sure.
They always do it in a 1 hour time. There's no
Okay.
exam that's less than 35 minutes.
Fair enough. And even as we talk about mole, we will talk about the chemical equation. So also a revision lah. I guess it's
Oh
okay.
yeah, by the
Let's talk
way,
about mole.
the homework I just want supervision. I won't really take a long time. It's just I want supervision because I'm not really that used to more yet. I might get it wrong sometimes here and there.
Correct, correct. No problem. As long as you're good with mole, I'm actually very happy. It's a very, 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 very important chapter. Yep, let's do it. Let's do it. I'm happy with your plan.
Okay. Let me get my
Sure thing.
so I'll get that one question that I cannot do. It's just one. So yeah.
Mm, are you concerned about part B?
Yeah, part B.
Can you copy and paste the question for me? Or screenshot, sorry. I want to zoom in a bit, yeah. I want to see your working, by the way. Just screenshot the whole thing.
Oh yeah, you're my working right? Yeah.
I'm just checking the M and the C for now, yeah. C is great. M is definitely great. Okay, your C and M is great. Now, when you intersect, you are doing it in a very weird way. Yeah? Okay, so I don't understand. I don't understand this. This one's great. This one's great. This one's great. Then, okay, part A, part B. This one, this zero, these two zero are very confusing me. Okay, now why would you do that?
Okay, K. Because I know there's both zero here. And I know if I get that, I'll be able to get K.
They are not both zero here. Only the curve is zero there. Only the curve and the y. Okay, yeah, which is, oh, you want to find K. I'm so sorry. I'm so sorry. You want to find K. I didn't realize that. No, you're totally fine. You're totally excellent. Okay, I cancel my question. Good. Now, in fact, your last line is what you need to do. This is so great. This is what they call intersection. When the
Yes.
line is equal the curve. Now, are you saying that you cannot continue from here?
I when if it I don't know how to use it in this.
Okay, so first thing first, I'll show you something very important. Oh, sorry, my drawing pad have problem with. Just a minute, sorry, just a minute. Give me some time. Sorry. Just a minute. Okay, now let's check out your last line. Your last line is admittedly one equation and one unknown. Make sense?
Yeah.
One equation by right is solvable by right. By right, yeah, by right. Now teach you something that teacher never say in school. I have no idea why they don't say. Look at the x here. The x here is the bottom and here is on the top, correct? On the power, so to speak. This kind of equation, nobody can solve. Not even professors of mathematics. Like nobody can solve, even though it is technically solvable. Do you understand what I'm saying?
Yeah.
There is no known technique to solve this. There's only one, and it's not algebra method, it's a guessing method. So it doesn't count. So this is solvable, but cannot be solved. Solvable, but cannot. Because the x is on top and on the bottom. There are actually other types that is also non-solvable, not just this type. But this type clearly not solvable, even though you're doing all the right thing. Do you understand what I'm saying?
Yes.
Now, that's why the question doesn't ask you to find x. That's why, because the question knows, cannot. Instead, the question asks you to do something weird, which is supposed to be easier than finding x. He is asking you to final answer, 2 power x minus x equals to 3. Now, certainly, it is very easy to do this. Certainly. Let me flip it to make it life easier. There, find this instead. Come on, man. You are very close to the answer. I cannot help you. I don't want to help you. I'm spoiling the question for you if I help you. Come on. Just go from this, your final line, into this. Cannot be that hard.
Oh. No.
Cannot be that
I
hard.
thought of doing that.
Yeah. And well, Yala, this is finished. So really, that's it. That's it. You are correct. You have gained all the marks. Excellent. Good job. Understand?
Just like that.
Yep. Because that's what they want. They want that. So you give them that. Full marks. Good job. Let's move on. Let's move on if you are happy with it.
Okay. I mean, if it's like that, sure.
Mhm.
Okay.
As per usual, screenshot for me, yeah.
Okay. So I feel like I could finish. Yeah, it's not a lot. I can actually finish it.
Yeah.
I feel I could
I hope
finish.
so. I hope so. So you're talking about the moles already. The mole seems fine to me. The MR seems fine to me. Okay. How about the ions then? Oh, hey, your question 2C not finished yet, eh?
Yeah, wait. Oh, yeah. I was thinking of something.
Yeah. I mean, B and C haven't finished. Yeah, B and C haven't. Okay. 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 So far, your answer is great. I like it a lot. This should be off, but that's it. Great. Looks good to me. Nicholas, are you stuck?
Yes, I've been satisfied to ask you.
Oh, you tell me lah, alamak. You tell me. Yeah. Look, aluminum oxide, is it ionic or not? Aluminum oxide is ionic or not?
Aluminum. Yeah.
Okay. Not enough clue because that's the thing that you have to think about. Not enough clue. Okay, then to answer B, might as well practice your exam, right? Draw the electronic structure lah. This will totally give you the answer. Draw first.
Let me.
Okay, might as well practice anyway, right?
No. When you say total number of moles of ions, right? And there's
Mhm.
Al2 and O3. Does that mean is it like 5 ions?
Each molecule of Al2O3 will give you five ions. Is that what you're saying?
Yes, because it's 5.
So the total number of moles of ions, is it 5.88?
Wait,
Is it?
I'm not talking about the moles. I'm talking about the amount of ions, not the total number of moles of ions.
Well, again, specify your question. The number of ions per molecule is 5. Correct. You're absolutely correct. You understand. So how does that relate to B?
That means can I wait. 5, they
B
say total
first.
number of moles. Doesn't that mean 5.88235 times 5?
Yes, that's it. Finish. Finish. That's it. Now this relies on your electronic structure, lah, which obviously you are correct. You understand things. Good. Done. Last question.
Wait, let me write. Number of moles of ion.
So are you gonna do part C?
Total number of ion.
Oh, you know the magic number, right? Okay. Magic number done.
29.41175 times 6.02 times 1023.
Okay. Just make sure your standard form is correct.
1.77 times 1025.
Yeah, great. I like it. I like it. Looks good to me.
Yes. Yeah. 1.75 times 1025, which is a okay. Can I ask a teacher?
Yes.
The relative atomic mass of deuterium is supposed to be 2, right?
Yeah.
Because it's one more
Correct.
neutron.
Correct. Good. This is isotope, yeah. Isotope is like one of the first few topics in the point is in exam, correct? Deuterium isotope IR2. Don't say mass. Alamak, don't say
MR.
mass. Say AR, man. Say AR. Not mass. Mass will be wrong.
MR of DT. MR of DTO is 2, 2 plus what's oxygen? 16. Now 4
Correct.
plus 16, 20.
Okay, nice. Continue. Cannot. The question wouldn't stop here. What? There must be
Yeah,
something
yeah,
else.
they want the molar mass. Okay, let me get the equation real quick. It's m over n, so they want a number of moles. MR is molecular molar mass. You know, MR is molar mass. What?
What's the confusion here?
If MR is molar mass, and the question asks us to find molar mass, that means 20 should be answered, right?
Yeah, done. No, done. You're done. You are correct. You are correct.
Then why did they say they shouldn't be there? Shouldn't be all.
It should be part C, I think.
Oh, you mean that? Oh no, it's done.
Okay. Nice homework, but it's okay. It's a revision for exam.
No, that's not the only homework. There's one more chemistry. One more.
Your take.
It's two more. It's two and three of it's actually four 3-part questions.
Sure thing. Sure thing. These are basics, which is to say these are very important. Let's do it. Let's do it.
The masses. Okay, what's mass again? Mass is n times molar mass. Number of moles times molar mass.
Do you have the mole in question A? Do you have the mole?
I need the number of moles and it's volume divided by 24.
Very good.
Wait, what? Huh? Where? This number of moles, and I want to find the volume and the masses. The mass is number of moles times molar mass. Steam. Isn't steam just yeah, steam is just water. And that's 2 hydrogen, yes, 1 plus
Yeah.
16.
Good. Yeah. Good.
That is just 18. And again, mass is number of moles times molar mass. Number of moles times molar mass. Make it 0 0.720 0.720833. 0.720833 times 18. 12 point. Wait, it's just 13.0 because it's a 12.97. Just 13. There you go.
Looks
Okay,
good
now,
to me, man. Hey, whoa. Wait. No, that's fine. You're correct. You're totally correct. I like it. Like it very much. Okay, now B.
oh wait, I forgot. Of H2O. Number of moles of hydrogen chloride. Alright, of HCl is 250 over 24. Wait, let me get the M first. Hydrogen is 1 plus Cl. Cl is 35.5. 10.4167. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now is, wait, this is the mass. Now it's mass of HCl is 10.4167 times 10.4167 times 10⁵ is 38 gram. So 3 yes, yeah. Now carbon dioxide. It smells something. Carbon is 12 plus 2, 16. It's 44. 0.658333. 0.6565833. 0.65833. 1044. 20, 28, 4, 29. It's just 29. Oh, what a gram. 29, 0.65833. That's my fault. 29.0, 29.0 gram. Okay. That is that. What is ratio of the volume? Okay, this is different.
Yeah, this is no, this is still basic, which is very good. It's very good. I still like the question.
The ratio of the volume of 2 grams of hydrogen. Hydrogen is H2, right? It exists H2. Hydrogen is number of mole. We have the mass. Okay, we need the number of moles. Wait, teacher, hydrogen exists as H2, right? Teacher.
You are correct. You're asking that just to be sure?
Yes.
Because you have to do that yourself in exam.
Okay, wait, methane is NH. Right?
That would be wrong, but that's all I can tell. Kindly try to find it yourself, or remember, you will need this in exam. This is not because of mole.
CH4.
Very good. Good.
Oh yeah, how am I supposed to find? Bro. I need to get the molar mass first. I need to get molar mass. I have the mass on it. MR of H2 equal to 1 or 2. MR of CH4 equal. Carbon is 12 plus 4, 1 is 16. So the number of moles, we get number of moles is N. So it's mass over molar mass. It's mass over molar mass. Mass over molar mass. Okay, wait. Mass 2, molar mass 2. Now mass over molar mass. Wow. It's the same. This is 1 to 1. Mass over molar mass is the mass in the molar mass. Mass molar. Why is the same? It's fine. And then I have the number of mole.
Correct. So how about the ratio of volume?
The volume. So they want to find the volume. The volume is number of mole times.
Ratio of volume.
Yeah. Okay, no. They want us to find the volume, though. The volume for the ratio. Volume for the ratio. So it's number of mole times 24 to get volume. So just I'll just do it twice. Let us to make it nicer. And it's just 24, just, yeah, 1 to 1. It's just 1 to 1. The volume is DM3, though. Should I put a DM3 there? Sure.
You're saying, sorry?
Should I put a DM3 here?
Oh, no. Ratios should be unitless. You learned that from math, and it is still the same here. A ratio should, like, both the m cube, right? So both cancel each other. If that makes sense? A ratio should always be unitless because they have the same unit. So, yeah.
Volume of CH4 equals 1 times 24 DM3 volume of H2 equals 1. Okay, methane again. Wow. The volume of methane first. The number. I have to find the number of methane molecules in it. I can find it. Again, MR of. I already have it technically, so that'll be easy.
Good.
Then
Yeah,
I wrote
nice
number instead of no, but fine. Wait, volume is wait. To get number of mole is it's mass over molar mass. Wait, I make sure. Mass, molar mass 16. Molar mass is 16 and mass is 12.6. Yeah, this number. Number of moles is 16. So volume. Okay, wait. Volume requires number of moles times 24. So this is 16 times 20. There we go. Then number of methane molecules. How do you find number of methane molecules? Teacher.
Wait a minute. Oh, yeah, okay, that's fine.
Teacher, when you say the number of methane molecules, Do they mean like 16 times 6.02 times 10 to the 4?
That would be the magic number thingy lah. Yes.
That'll be for B, right?
Sorry, you're missing something in the volume. You're missing something important in the
DM3,
volume.
DM3, DM3.
Yes, very good. Thank you. Other than that, B, you're correct, Lo, and C, you should be able to do it also.
Wait, so B is CH4. So it's 16. Wait, no. Yeah. 16 times 6.0 times 10. That is right. I got, yeah. 16 times 6.02 times 10, 20. 16 times 6.02 times 6.02 times 10, 20. 16 times 6.02. Number of CH4 molecules is 16 times 6.02 times 1023 equal 9.63. Number of H. This is a covalent bond. Number of H atoms in molecules of covalent bonds. So okay, wait. The number of H atoms, right? It's this part. It's this times 4 times the magic number again, right?
Okay, think
Wait.
about it for a while.
No,
Sorry, wait.
It's this times 4. It's this part times 4.
You're correct. Good. Now, let me test you. How come your B has no units?
Because it's not mole. It's not because it's a number of methyl molecule. It's just a number.
Very good. Very good.
This was the correct answer. I just need that. 9.632 times 24 to 9.63 times 24. Then it's 9.63. Oh, wait. Right. Number of each atom is 9.632 times 1024 times 4. 9. Okay, wait. 9.632 times 1024. 9.632 times 1024 times 4. 9.632 times 10. Why did I write 23? 9.632 times 10, 24 times 4. That is 3.85 times 10 to 5 to 3. That's 3.85. After 5 is a 2, so it just round down to 3.85. 3.85 times 10, 25 to 3. Okay, that's wow. Uh, oh, phosphorus trihydride. Hydride. What is trihydride?
You cannot guess what is phosphorus trihydride.
No,
It
no, wait,
is
no, no.
not
I'm
in
trying to guess.
your.
Okay, okay, wait.
It is
If
not in your. It is not in your
okay,
notes.
wait.
Probably.
No, no.
Probably.
The problem is right.
Mm-hmm.
Since I'm guessing the word high dry means
Yeah.
hydrogen, but like it's just the word I that like throws me off. Like, is it something else? The word I.
Okay. Now here's the good news. The word hydride does exist in your school notes. You gotta see that first. Not trihydride, just hydride. Maybe lithium hydride or something like that. It will exist. Your school notes are quite good. You check it out. Then your guess doesn't have to be a guess anymore.
Okay, it's hydride. Just okay. I can. Hydride is just oxygen. It's just hydrogen.
Yeah, according to your notes, right? So trihydride, there is nothing to it, right? The word tri, you already know what it means. What
H3.
is tri? Yeah, that's it. Right? Three hydrogen. I mean, fancy way of naming it, right? Just three hydrogens, right? So molecular formula. Okay, that is a good guess. You'll be doing this in exam lah, once or twice.
The mass. You want the mass? The mass. The mass means number. Number of pH3 molecule. Wait, I wanted to stay consistent. Sorry. Number of moles of pH3 is volume divided by 24. So it's 324 over 24. Volume divided by 24. So that's 324 cm3. That's the volume divided by 24. The number of moles. So I still have the number of moles and the molar mass. I guess find the mass times because it's just times. Mass of pH3. Mass is molar mass times number of moles. 13.5 times 34. 13.5 times 13.5 times 34. 13.5 times 13. 13.5 times 34. 459 grams. The number of phosphorus trihydride. Well, I already have that.
Mm-hmm.
And then total number of atoms. Well, that's not that hard. That's just 13.5 times 6.0. number of pH3 molecules. Wait, the total number of yeah. Is it the total number of atoms?
Yes. Does that bother you?
No. Let me I'm just thinking of how to write this part. Let me guess. pH3 isn't it just this part times 4?
Yeah, that's it. Finish. Done.
Okay, let me number of pH3. Okay, number of atoms in pH3. There we go. Number of atoms in pH is equal to 13.5 times 6.02 times 10, 23. 13.5 times 6.02 times 10, 23 times 4. 3.25 10, 25. Okay. Okay, wait. 3.2.5.08, but that's just lower. But that's just lowest is round down. So it's 3.25 times 10 times 10 times 10, 10, 25, 25, 3.25, 25. Okay, that's that. All the homework's done.
Very happy that you seem to understand things. Very, very. And your school, the way your school teach is nice. It is good. Have I ever told you that your school is in general good?
I think so.
Good, good, really good. I'm very happy.
Uh,
You're also a good student, lah. I, if I haven't said that a few times, I want to say that you are in general also a good student. Good student, good school. Very happy. Very, very.
Thank you.
All right. Now, what shall we do?
Have a break. Teacher.
Yes, sorry. I cannot hear you just now. Sorry.
Okay. Before, I feel like I want to do some chemistry revision. But before that,
I think so.
we have a break.
Sure. 5 minutes. See you soon.
Okay, teacher. Hello?
Apologies, I'm muted. Do you have something to practice, or shall we go to Google Drive?
I think you should go to Google Drive.
All right, go there. SA1, SA2, Sec 3, Sec 4 does not matter. You will find a lot of questions to help you practice. Sec 3 slightly better lah, I must admit. Just easier to find the question.
So do Google Drive, right?
Yeah.
I see.
Focus on Sec 3. Focus on Sec 3 if possible as A1. But if you don't have, doesn't matter.
Sec 3. Wait. I only have O level and O level chem. You only gave me O level chem.
No Sec 3? No, there
Yeah.
should be. Inside the O-level chem, there are Sec 3 folder. Check it out.
Oh, there is.
Okay, and inside Sec 3, there might be SA1.
Yeah, there is. A lot, actually.
Yeah, go to SA1, and yeah, you have a lot of practice. Nice,
CHIJ.
good practice. Sure thing. CHIJ is good.
Oh, wow, there is answers ready. Good.
Okay, go to paper 2, okay? Not MCQ. Don't practice MCQ.
You mean section B and C?
Section the long questions. Don't practice MCQ. No point.
Yeah, okay. Section B and C. Section B and C. We'll do. How about 2 section B's and 1 section C?
If you could do that much, that would be great.
Problem. So all of them have answers ready.
Shift to another school. Just wait. See.
Oh, East Spring. Literally. Oh, that's
Sure.
SA2. Wait. That's
SA2.
Hillgrove, my brother.
Sure.
Oh, my SA2. How about Bedok View? Just find the SA1. Okay, paper 2. Oh, my section A again. Section, yeah, it's SA1. Is it section B? I find it section B. Chromatography. Ethanol was used. Sudan orange. Mali blue. Chad yellow. Is this solvents? Physical properties? This isn't what the thing, right? This can't be. Let me make sure. It's 2, 3, 4, 5. Okay, wait. Okay. No. Chem is 3, 4, 5, 6. Okay. Okay, I know it's not this.
Oh, don't take too long, alamak.
Yeah, no. Okay, it's a filter. These are all filter questions. The entire
share screen to me, and then I'll just choose one. Come, share screen. Okay. Choose your Bedok view. It's fine.
No, I already chose it. That one got nothing. That's all.
Okay, good. Good. Let's go to paper 2,
This is combined.
which is not what we want. Not what we want. Yeah, you're right. Not what we want. Science is science again. Alamak, alamak. Let me see the folder. Go. Let me see the folder. Hey, how come I didn't? Okay, go to pure. You go to pure. Down. No, down. Go down. Go down. Okay, pure chemistry, SA2. Pure down. There's no SA1. Doesn't matter. SA2 will have a lot. Go for pure chemistry, SA2, whatever again, and Seng also can. Okay, CSIG. Let's go. Go. Paper 2. Go. Don't worry, you'll get the. Okay, stop there. Stop. Go to B1. Go to B1. Come on, go to B1. Quickly go to B1. Alamak, go up. Okay, B1 definitely definitely right. Definitely.
Yeah.
Go to B2 first. Go to B2. B2 no. Maybe B2. Maybe D2 just the first part. So no. Okay. Let's forget about B2 for now. B3.
By the way, it's all about atoms. It's literally just everything about atoms.
So B3 is acid and base. Let's skip B3.
Yeah.
B4. Oh, this one. Cannot. You cannot do that.
This part B of this. Oh my.
Yeah, cannot do part B. So now B4. B4. Yes. B4, yes, is a slightly fancy more question with reaction lah. Should you do it or not? Maybe not. Yeah, so never mind for now. Never mind. You haven't reached that. Let's go. Let's move. You haven't reached this. This one is also a mole. A mole question also. Too many mole question already. Okay, go down. The weakness of SA2. This is redox. You haven't talked about redox. Oh, scary. Let's go down. This school is scary, yeah? Enthalpy, haven't. Oh, no. Oh, no. Point C. Melting point, boiling point, definitely you need to talk about this. So this is definitely, definitely your exam, definitely. Okay, so C1. Let's go to C2. If there is a C2.
Pentane. What?
Yeah, never mind those things for now. Never mind. C2 is not, because there's a no, C2 is not. No, okay, okay lah. So B1 and C1 lah for now.
B1 and C1.
Yeah, the weakness of SA2.
Okay.
Still good practice. Very long question anyway. So.
It's a really long question. And C1, right? Okay, this is good. This is good.
Okay, you can stop your screen sharing. Yeah? Stop it. Oh my god. Definitely B1 is definitely.
This is a big question. Okay, I have to be forced to use of page 7. But I don't really think I'll need TD because wait, explain why the density. Huh? That one I don't think I remember.
Oi, I'm gonna filter the question. You do B. I already filtered the question already.
Okay, definitely let me take my notes. Let me take my paper.
Definitely in. Yeah, definitely in. Okay.
Okay, wait, so B part 3, right? B part 3. Okay, so complete following table. Substance: potassium bromide. Bromide. So potassium bromide is just potassium and bromide, right? So that's an ionic bond.
Good, good, good.
Let me write it so I'll actually understand.
Or you can type in the Jamboard. It's up to you. Up to you.
Yeah, but this is gonna be used for my reference, so I can actually like
I like it.
revise.
Don't mind. Don't mind at all.
Ionic bond, then iodine. Well, just by itself. Well, okay, that's a covalent bond.
Yeah, yeah. Now, there's something a bit bad about the question. This should have been written as gigantic covalent bond. So, a bit not very nice lah. And the iodine should be simple covalent bond. I think some teacher emphasize that fact lah. Gigantic versus simple. So maybe we just practice it that way lah. Gigantic and simple covalent
I mean,
bond.
it's a WA1. Would it really be? I know, just in case lah. Okay,
It's
how
not
about the
WA1.
potassium?
It's WA2. This is WA2 already.
No, it's still WA1. WA1 is.
I am so sorry. Iodine is not simple. I am so sorry. Why? Because they show us this. This is not simple.
It's a giant.
It's also gigantic. Iodine is also
They're
gigantic.
all giant.
Yeah, all of them are gigantic.
Since they're all giant, isn't it? Doesn't it make no difference if I just put ionic?
Ionic is always gigantic. That one no need. But covalent can be gigantic or can be simple. Ionic no need. There is no such thing as a simple ionic bond.
How about I check the answer sheet whether or not we do?
Sure thing. Remember, this is the answer sheet of another school, not your teacher's.
Yeah, but it should still. But it's an old. No, this is an old level. Wait, this is SC2. Never mind.
This is Sec 3, Sec 3 SA2. Sec 3 SA2. Which is very weird that they don't
Okay,
emphasize
no,
gigantic.
it's even more different. For iodine, it's intermolecular forces of attraction.
Oh, the attractive forces between particles. I am so sorry. I didn't read that one. That was my mistake. No, that was my mistake. That was really my mistake.
So I'm still wrong. No. Well, this
Okay,
is
we
just,
gotta talk
I
about
mean,
this, man.
it's
Do you know or not? Do you know why it is intermolecular
because
force?
by itself, it's just attracting by itself.
Well, the attraction here is not based on sharing, lah.
It's based on just by itself. It's together. It's a lonely, called a lonely seven, that's why, right?
Well, first time I have to ask you, do you understand the intermolecular forces thing?
Does it seem like I don't? I feel like it's because it exists as iodine too.
It does. It does exist as iodine too. So the only covalent bond is between I and I, lah. The
Yeah, that's why
sharing
it's
part, right?
intermolecular.
But it's gigantic. So it's not that I2 is sharing with another I2, lah. So you cannot say covalent bond. Oh, my mistake, yeah. Really my mistake. I'm so sorry.
So intermolecular. Wait, do I have
So
to
the
say
other answer is
intermolecular
still
and it's for ionic
intermolecular.
bond?
For now, lo. For now, it's like that. For now.
Wait, let me see my own textbook.
Yeah, even the textbook will not cover iodine, I think. Very interesting question. Now that I think of it.
This is weird. Ionic
Very
covalent
interesting.
bonding, 69.
Very interesting.
A giant. This is a giant covalent bond, right? Or is it not? Wait, that has to be. Iodine exists as a simple. Iodine is a simple covalent bond. If it's a simple covalent bond, why must it be different, teacher?
I'm so sorry, you're saying?
Why can't I just write covalent bond and not intermolecular? And why do I have to write intermolecular force of attraction and not covalent bond?
Intermolecular forces of attraction is not covalent bond. That's the whole point. That's why I asked whether you understand that part or not. That part certainly will be tested. It will. Do you understand that it is not covalent bond?
Okay, it's
Not
not.
at all.
And then why is it?
Why is it there? I mean, well, I'm gonna draw an I2, okay? I'm just drawing something like this, right? That's your I2, look. There, it overlaps. There you go. Ta-da! There is your covalent bond, right? Covalent bond talks about sharing, talks about overlap, that kind of thing. Okay? Okay? And then, if this is H2, here's another H, and this is another H, H2. There is some sort of attraction, some sort, very weak, between H2 and H2, very weak. You will call this very weak interaction. It's not nothing, nah. It's not nothing.
Oh wait, it's interactive. It's interactive force between particles.
Kind of attractive, very weak attractive intermolecular forces. And you have to explain that this is the reason why the BP very low. Correct? That's just a standard explanation. Now, iodine, the BP very high. The BP very high. The iodine BP is very high. The melting point also very high. So you gotta explain it as the, intermolecular attractive forces rather strong. Here's another I2. The kind of thing here is rather strong. So leading to that. And that is what they're drawing kind of ish.
Okay, not. I'll write that down. Covalent
Because
bonding.
it's, oh goodness me, see, they go to part 2, exactly what they usually do. Look at part 2, exactly what they want. You gotta describe that the iodine is solid.
Oh, you said that the melting point. Yeah, the melting point is high. So yeah, should be wait. I mean melting. I mean it's solid.
It's solid. Oh, solid.
Okay, wait, so He is
no. They just change the question to explain. Right?
Wait, teacher, you say He like. Teacher. One's H2.
Yes, sorry. Your mic not so good, sorry. Your mic, you're saying?
It's H2, right? That's H2.
You want to draw my H2 as a comparison, is it? Yes, yes, it is. I'm just comparing H2 with I2 lah.
Yeah.
Sure thing. Sure.
Why is iodine different? Why is iodine strong?
The reason, surprisingly, in your syllabus, they don't ask you why it's strong. But you must notice that they're strong or weak. Or you must use that as an explanation for BPMB.
Wait.
But
Covalent bonds, right? Usually it's weak, right? Like almost everyone.
Wrong. You are currently wrong. Please listen to me carefully. The covalent bond is strong. The intermolecular force can be very weak. You are wrong to say that covalent bond is weak. Covalent bond
the bond,
always
is strong, but the
Yes.
intermolecular forces
There
of
you
attraction
go.
between
Can be very weak.
each particle of covalent bond is weak.
Yes. In general, iodine is an exception. Right? Iodine is an exception. In JC, you learn the additional reason, just one reason. Oh, iodine AR very big. Big AR tends to cause higher intermolecular force. You don't need this in O level, just want you to know. One more time, get rid of the concept that covalent bond is weak. No, covalent bond is strong. Something else is weak, and that's what they're trying to,
There we go. I've written it down.
So remember to use this in exam. Almost confirm will be used one lah. That's just their line of reasoning.
Okay, so graphite. That's just carbon. There's just lots and lots of carbon ion.
So carbon.
Wait.
You must, however, mention carbon atoms or carbon ions lah. At least you must mention them.
No wonder something fell off. I actually wrote ionic bond instead of covalent bond. It's carbon atom because it's covalent bond.
Better to say atoms. Huh? Yeah.
And then iodine is just iodine
atoms or iodine molecules or I2. No, you better say I2 molecules.
Yeah, iodine
better
molecules.
Say that.
Also iodine
Better say that. Better say that. That's just more precise.
Okay, let me see the answer sheet. And I'm correct. Yeah, iodine molecules, carbon atoms, iodine bonds. Only exception is that I look at the answer sheet is intermolecular force of attraction, but that is describe
intermolecular.
Yeah. Describe the movement and arrangement of iodine at room temperature. The movement of iodine. When they say the movement of iodine, do they mean like when it moves around randomly because it's a particle?
But it's solid particles don't do that.
Oh wait, yeah. It's fixed in a orderly manner.
Yeah, I guess.
It vibrates about fixed positions, as my textbook says.
Yeah. And the arrangement is a lattice law. I think that's the best phrase you can use for the arrangement. It's a lattice arrangement. Like covers all bases, I guess.
Oh my, it's right here. Simple covalent bond molecules. Where is it? Apparently my textbook doesn't say that. I just should know it. So yeah, it vibrates about fixed positions in a it vibrates. Okay. Iodine. I should say molecules, right? Iodine molecules vibrate about. Let's say vibrate about. Sure.
Vibrate about in a fixed position and are arranged in a lattice.
Are what arranged in a lattice?
Yeah. A lattice is the fancy word for, orderly, fixed, gigantic arrangement kind of thing.
Gigantic.
Which yeah, it's gigantic. It's just that it's not gigantic covalent, but it is gigantic still. Lattice has always meant that it is gigantic.
But it's an iodine a simple covalent bond?
You can no longer say it is simple molecular. Cannot say it. Because even though the molecule is simple, fair enough, but it is arranged in a way that it is solid, very not typical. Correct or not? It is not typical at all.
Yeah.
And that is why the question exists to test you whether you
Haven't I
can.
seen iodine before?
Check it out. Check it out. I'm glad I did this question with you. Definitely.
I have seen iodine before. I heard I the thing is, right, I'm very confused, right? Because I've definitely seen iodine liquid state before.
Liquid and solid. So a bit mistaken here. It's both liquid and solid.
Wait, are those like medical iodine bottles
Yeah.
just diluted?
Yeah.
Like are they just iodine solids like in water or something?
Definitely iodine is kind of rather soluble, kind of ish. The iodine that you see are not the pure iodine. It's the iodide. What you saw was iodide. Iodide is iodine ion. Okay, okay. Nice. Yeah, I know what you saw. What you saw was not iodine. It was iodide.
What? So
I'll
they're
show
two
you.
different things. That's all I need to know. They're two different things.
I'll show you.
Because you see, okay, and are arranged in a lattice. Lattice means what again?
Informal definition. Informal definition. A very nice arrangement which repeats itself infinitely, kind of something.
So regularly, so just a regular orderly arrangement.
That's your
Like-
fancy regular arrangement.
But it's a giant covalent bond.
It's not giant. Oh, goodness me. It's gigantic, but it's not covalent gigantic. It's gigantic because of the intermolecular forces. It is
Gigantic
possible.
as in like, you mean it's not uncountable, it's just that it's big.
It repeats itself indefinitely. It
So it is
repeats.
uncountable.
Yeah, it's not well, it's countable in terms of molecular, if that's what you mean.
No, because when they say giant covalent bonds which have a practically some covalent giant molecule, not giant covalent. It's giant molecules.
They are also not giant molecules. Their molecules are not gigantic. Their molecules are small.
No, they say some covalent substances exist as giant molecules which have a practically uncountable number of atoms in each molecule.
Yeah, which is not what we are seeing here also. That it's not. Our DNA is giant molecule, our DNA, which is totally not what we're talking about.
How about I stick to my simple definition just so I don't accidentally use this wrongly? Because you said loosely, it just means orderly arrangement, giant, right?
Yeah, correct. That's what lattice means. Orderly, gigantic arrangement, repeating itself. That's all. That's all it means.
A simple molecular lattice.
A simple molecular lattice also does not work. By the way, what's wrong with using the word lattice? You see, you're the one that asked for the definition, you know. The question does not ask for definition, you know.
A lattice is a three-dimensional arrangement of ions or atoms in a crystal. Giant ionic lattices are referred to as giant, as they are made of.
I mean, if it helps you, sure thing. I mean, there are fancier words there.
If I write lattice, it doesn't really. I cannot.
When you write lattice, you're accepted. It's what I'm trying to say right now. Lattice works for the examiner. They like the word lattice. Hey, lattice.
Lattice is arranged properly.
Orderly
Yeah, yes, I mean.
Orderly repetitive arrangement. Orderly repetitive 3D arrangement, if you like.
Okay, orderly arrangement. So then other things?
That's it.
That's all.
By the way, here's the picture of iodine so that you're not confused. Iodine are solid, although it emits a lot of gas. It kind of sublimes very quickly.
I know it sublimes. I've seen that happen in a video.
The point is there is a solid part of it. The point is that the solid.
That is iodine. Okay. So now it's 7:30.
I will see you next Monday, right?
So wait. Before I go, just to make sure. Lattice means orderly arrangement. And nothing.
Orderly repeating 3D arrangement, I guess. Something like that.
Repeating
3D arrangement. And I will add, doesn't have to be ion, doesn't have to be atom, doesn't have to be molecule, can be anything. So that's why they say a lattice of ion or lattice of molecule or lattice of whatever. They do say that.
Can be any particles.
Can be any form or sort of particles. Can be. You're right. That's why it's a very general word. I mean, a HDB block is in a lattice arrangement. Fancy word for the arrangement is orderly, you know.
So technically, could I say any covalent bond and that is a solid, and I call it a lattice?
No, it's certain sorry, let me put it this way. Almost all solids are lattice, except for glass, which you don't learn anyway. Almost all solid in O level will be a lattice of some sort.
Almost.
The exception is glass, and you don't learn about glass at all. You don't learn about glass. So doesn't matter the exception. So in O level is all solids. All solids are lattice in O level. In reality, is almost. So it's okay lah. Not so bad.
It's nice. Except for glass. That's one exception. But who cares? Yeah. It's not going to be tested.
Which you don't learn because you don't learn about the glass.
Okay. Good for me.
Okay? Okay. I'll see you on Monday. Hopefully we can talk more.
Bye-bye.
Good job.